Module 10 of Unit 2, uh, Island Biogeography. So, our learning goals for this unit are describe how island biogeography affects the species that which live on the islands. We're going to identify what determines the number of species on an island, and finally describe why some species on an island are particularly vulnerable to invasive species. So, starting with that first standard, we're trying to learn the study of how species are distributed and interact on islands is called island biogeography. So, typically, larger islands have more species due to resources available, and islands that are closer to the mainland also have more species diversity. So, for example, as the species of reptiles and amphibians on an island in the West Indies are measured, it showed the relationship curve between size and species number as the species area curve. So we can see that the bigger the island, the more species it had on it. So down here on our x-axis is island area in thousands of kilometers, and then this is our number of species. Okay, and then if we look at that same thing again on a log view, it just keeps going. And it's pretty interesting because no matter what type of animal you're studying, such as reptiles, mammals, birds, it generally follows a curve of about 20 to 30 as the increase. So, pretty interesting. Um, like I said, this works not just for reptiles, but they found that it's also very similar for other mammals and lizards and frogs and birds and insects and things like that. Many studies on island biogeography initially focus on oceanic islands, but any isolated habitat can also be included, such as terrestrial landscapes. So, your book references a wetlands, and that is on page 114. So, the wetlands sometimes would become obviously cut off from everything else if there's a lot of flooding. It also references mountaintops, which is kind of interesting because you do have that timberline where the tree stops growing, but you still have some habitats up there of mosses and lichens and things like that, and animals that might eat those things. And so these graphs are of wetlands, and you can see that they are very similar. So as the wetland grows in size, you also get more plants. As the wetland goes in size, you also get more amphibians and reptiles, and you get more birds. Not as good as an incline, but birds fly around, so that makes sense. They can kind of move a little bit further. And then mammals as well, maybe not traveling as far, but there's still a steady increase. As you can see, the relationship there. As your land size get bigger or your habitat gets bigger, you have more animals or organisms. Okay, so size of the island does affect the number of species and ecological relationships. This kind of seems like a duh moment, but if you have more area, it seems like you might have more resources. More resources means you can support more things, right? Um, so the bigger you are, the more fauna you can support, or the more plants you can support. And so you need producers to support ecological efficiency, right? So we always start with our trophic pyramid, and it has to start on the bottom. And so this is our producers. Oh, here we go. Okay. And so everything rests on the producers. So if you don't have a lot of area for producers, you're not going to be able to get our primary consumers, and then definitely not our secondary consumers, right? One other thing with that is typically small islands cannot support a large number of predators. So your producers won't last, right? So if we don't have any tertiary consumers or lions or big animals that are eating our secondary and our primary, these primaries are just going to wipe their producers out, right? Because if there's nothing to control this population, it is just going to wear it out and wipe it out. So we need a big plant population to be able to support primary consumers and secondary consumers and big predators. Okay, so it takes a lot of area for that to happen. This graph right here is the effects of islands on ecological relationships. So it says a small island has a high mortality rate and small recruitment rate. And so the book defines recruitment rates of trees reaching the sapling stage. So they reach sprout, but they never actually grow into a baby tree. So you can see that there is definitely a relationship. So a small island has a high death rate for these plants because the primary consumers are going to eat those. They're herbivores. So a lot of them are dying, and not a lot of them are making it to that sapling. And then medium, you can see it is still decently high mortality rate and still a low recruitment rate. I think it's interesting that this is actually smaller than the small island, so they last even less time. Maybe there's just more variety. And then finally, our large island has the lowest mortality rate and then the highest recruitment rate. So there's more area. So they have the ability to support more producers, or at least they're spread out to where it can be a little bit balanced. So we're on 10.2, and it says identify what determines the number of species that live on islands. So besides land size, what we just talked about, it is also determined on how far or close something is to the mainland. So this is our mainland right here. Okay. Here's our people. Okay, and this is our bird. So our bird is going to always choose to fly somewhere closer than it's going to fly further away. And why is that? It is, they're not really sure, but you think it would probably be because it's going to be closer to the mainland, which looking at our big island versus small island is going to have more resources, right? But generally, what happens is if the islands are the same size like they are here, animals are going to choose to be to the closer island because it's not as far of a travel, okay, as maybe this one is over here. And if you need to travel back for resources, it's not that hard. Case studies show that larger, closer islands have higher species numbers, which definitely makes sense with what we just talked about. So again, this is another chart. If you notice, we look at a lot of data in this unit. So the number of bird species on the log scale and the area of um, the island, and also how far away the island is from the mainland. So you can definitely see there's a relationship. They have the highest amount of birds on islands that are the biggest and closest to the mainland. And then intermediate, again, we have pretty much follows the pattern we would expect it to follow. So the closer you are and the bigger you are to the mainland, the more different species you're going to have. Okay, so through various experiments over time, a model of the island biogeography has been developed. So, a gentleman by E.O. Wilson and Daniel Simberloff conducted an experiment on some islands near Florida. And so, what they did is these islands typically only contained mangrove trees, and there wasn't too many animals living there except for bugs. So what they did is they tinted the islands and fumigated it, killing all of the bugs that live there, and then they would go back. I think it was weekly, and count how many different bugs or things like that started to colonize and come back, and how long it took them. It was pretty interesting. So, determining the rate of colonization, the rate of extinction, can help determine the number of species on the island. We'll look at a image next where those two things interact. Because resources are finite on the island, colonization begins to slow and extinction begins to rise. And then using models given, we can guide how to preserve biodiversity in national parks, forests, and refuges. refuge. So let's go ahead and look at that and talk about it. So this is something they use to help identify how many species can survive on an island. And so this blue curve represents the rate of extinction. So you can see that it goes up as the more species you get, and then our rate of colonization. So as there are more species there, it tends to slow down. And why do we think that is? Well, that obviously would be because there's less resources to go along, right? So as more species moves in, the rate of extinction goes up because there's more competition. There is this point in the middle that's called an equilibrium. If you don't know, an equilibrium is where the two lines will overlap, and so that is the perfect balance where there is the right amount of species living there for the right amount of resources to be provided. Okay. And so, why does any of this actually matter? So, it matters because we can use this information to determine um, how much land we need to set apart to protect animals or other organisms, right? So we've determined that larger areas are going to be able to support a higher rate of biodiversity and higher populations, which, as we know from our last two units, or excuse me, our last two modules, makes the uh, ecosystem better and more able to survive natural disasters or disease and things like that. And so they're going to have an easier time bouncing back if something happens or being able to resist it altogether. And that is important because, and when we're talking about legislation and being able to change things, like such as in what's the whale worth, right? It takes people knowing what we actually need to do and voting on those things. So we need to protect Yellowstone National Park. That's a big area. And the reason why it's a big area is because we've determined that bigger areas can support higher rates of biodiversity, protecting our different organisms. Okay. So then finally, we're on 10.3. So describe why some species on islands are particularly vulnerable to invasive species. So species that evolve on islands tend to be specialists, which means they can only live in certain scenarios because they haven't had to try to adapt to things. So, for example, there is a bird that lives in some of the islands around New Zealand that no longer can fly because they have just not had to for such a long time, that it's something they lost along the way because they didn't have any natural predators that were eating them on the ground, or in other places around the world in those same islands. Birds don't build their nests in trees because they're not afraid of predators eating their eggs and things like that. They also do not have a variety of food sources that they'll eat. They'll be adapted to eat certain things, and that is not good. We'll talk about that in a minute. And then, yeah, they just can't tolerate a wider range of other species interacting or hunting them, and those animals or organisms are going to be more susceptible to change affecting their lives. So what happens is, somehow accidentally or on purpose, a common generalist can will be introduced, such as maybe you're discovering an island and you had some mice on your ship that escaped, or there is an example of the brown tree snake that got onto an island from a ship from Guam and took over because the other species were not ready for it. And what happened, especially in that brown snake example, it had an easy time picking off its prey because its prey had no defenses on it. They didn't even know that it was a danger. The trees and things like that had not evolved to have any self defenses because they just hadn't had that predator. So they were out competing the snakes that already lived there because nothing new to be afraid of it. And so they were eating uh, the prey that was supposed to be around for everybody, right? And nothing had a defense, or the mice, okay, that nothing had a defense, so they went through and they ate all the vegetation because nothing was competing against them that could keep up, right? Um, so yeah, so mice and rats have a history of wreaking havoc on island species because they're able to consume native food sources and also can be predators to native species, so they can eat bugs and things like that. They also tend to carry pathogens, which our native species on the islands would not be able to protect themselves against because they wouldn't have been introduced to them. And that was kind of the whole idea behind the original lockdowns when COVID was in whatever part of the world it started in. I think it was China, right? We didn't want that coming over here because we had not developed the ability yet to fight off COVID, and that's what the lockdown was trying to do. Scientists estimate that roughly 50% of extinctions in the 400 years have been island species because they're just not well adapted when new things come around.